Astronomers have found clear evidence of what could be an Earth 2.0. This artist rendering shows the rocky planet identified as Proxima B orbiting the Proxima Centauri star.
What has astronomers uncovered with the James Webb Telescope, our eye in the sky? Is there anyone else in the world than us? This question is not new. Some frightening objects that resemble humans have been discovered by the James Webb Telescope, although they are quite far from Earth. These findings bring us one step closer to the solution. Many people have searched for existence beyond themselves in every society. There are a ton of books, films, and concepts on this subject. We've always felt alone and wondered where we fit in the world. We seem to be hardwired to seek out friends, no matter how strange they may appear. We might be getting closer to the answers we truly desire. Are they truly that frightening, even though they might provide the answers we seek? Join us as we explore the most recent findings in the realms of planets and galaxies in an effort to uncover something we may not be prepared to witness. It may be the most significant discovery ever made by scientists. The launch of the James Webb Space Telescope in 2021 raised an intriguing question regarding the potential capabilities of our technology. Whether our telescopes could detect artificial light on another planet in the future was the question. Proxima B, the closest asteroid to Earth, is located 4.25 light-years away in the habitable zone of Proxima Centauri, the nearby dwarf star. Proxima B was believed to be tidally locked, meaning it always had a day side and a night side, despite being 20 times farther from its star than Earth is from the Sun. The way the Moon always faces Earth from the same side is similar to these phenomena. Photovoltaic cells, which convert starlight into energy, might be used to transfer power and heat from the day side to the night side in a hypothetical modern community on Proxima B. It was then demonstrated that future telescopes would be able to see that solar panels cover a significant portion of the day side in a study that involved Manis Lingam as a researcher. It would be feasible to search for artificial lights on exoplanets that might harbor life, such as Proxima B. The James Webb Space Telescope might have done that in 2024 because it was more sophisticated. With its increased sensitivity and broader capabilities, the JWST might have discovered the lights we were searching for. The next significant development in human evolution might have been accelerated by this. To understand how this is all feasible, let's first take a closer look at planets and exoplanets. Finding out what Proxima Centauri B is concealing is James Webb's responsibility. The natural environment has long piqued people's curiosity. Man started attempting to answer the common, yet extremely difficult issues of who we are, where we come from, and where we go as soon as he became aware of himself. Despite the fact that technology is always improving, it raises the question of whether we have come any closer to providing answers to any of the aforementioned queries. A philosopher would probably argue that we still know nothing about the world or ourselves. The same question will make an astronomer jump up and down with excitement as he hurries to inform you about the most recent exciting discovery made about the world. These instruments are genuinely evidence of human evolution, even though the average individual doesn't give them any thought. It's time to reach the sky now that we can reach the world with our fingers. Researchers and scientists have discovered one method for doing it. We accomplish this by using technology. A particular piece of that equipment is responsible for the most recent detection of what may be light on a separate planet, light years distant. The James Webb Space Telescope is this. The James Webb Space Telescope, of course, is the result of the efforts of those who have before ventured into space to answer eternal questions. Is there nobody else around? Who's there? At what point do we begin and finish? Some of these concerns have already begun to be addressed by this infrared stargazing equipment. Nevertheless, you could first be curious about what Proxima B is. This is the super-Earth world Proxima Centauri B, also known as Alpha Centauri C, orbiting a M-type star. Still uncertain about an M-type star in a super-Earth world? Don't worry, this film will address all of your significant inquiries. Super-Earths are a class of planets that are larger than Earth, but lighter than ice giants like Uranus and Neptune. They are quite special. They may be composed of rock, gas, or even a combination of the two. Their sizes vary from 10 times the Earth's surface mass to twice its size. I guess you put the super in super-Earth. In addition to being an exoplanet, a planet outside of our solar system, Proxima B is also a super-Earth. In 1917, the first potential indications of extraterrestrial life were discovered, but they sparked little recognition or attention. When they made their first positive discovery in 1992, scientists were stunned. Another exoplanet, distinct from the ones discovered in 1988 and 1989, was demonstrated to exist in 2003. As of April 1, 2024, there are 4,161 planetary systems with 5,653 known extrasolar planets. Of these, 89 had multiple planets. These incredible discoveries are now circling an M-type star. You must understand the red dwarf before you can discuss the M-type star. Red dwarfs are the smallest stars in the main sequence, which is where the name originates. The red dwarf is by far the most prevalent star type in the Milky Way. Near the Sun, they can be found. Red dwarfs are difficult to see since they don't emit much light, and brightness is one of the primary ways we locate planets and make other types of assumptions. The cunning star has various names and meanings according on its size and warmth. M dwarfs and M-type main sequence stars, which can reach temperatures of up to 3,900 Kelvin, are a couple of examples. This is the origin of their names and traits. Returning to Proxima B, we can determine that its mass is equivalent to 1.07 Earths. It's fascinating to note that our star takes 365.25 days to complete one orbit, whereas it only takes 11.2 days. The size of the star that Proxima B is circling is obvious. Using the entire electromagnetic spectrum to evaluate brightness, the star is surprisingly only around 0.16% as luminous as the Sun. Because it emits far less light energy than the Sun, it appears fainter in the visible light spectrum, where the brightness seems to decrease even further. In the visible light spectrum, it only shines 0.056% of the Sun's luminosity. It emits infrared light, which makes up about 85% of its energy. In 2016, it was announced that Proxima B has been discovered. It circles around 0.04856 astronomical units from its star. Perhaps you're wondering, why Proxima B? The universe is home to millions of stars, planets, and galaxies. So why do we care so much about this? Of course, this location piques the interest of scientists for a few reasons. Given that Proxima B is the closest star to our Sun, it is also the closest star to us. 4.2 light-years may seem like a lot to us on Earth, but it's a tiny speck in the universe's vast scheme of things. Proxima B, the closest star that we are aware of, is crucial because of this. Additionally, it is currently a part of Alpha Centauri, a triple-star system. The system is among the brightest in the night sky, ranking third after Sirius and Canopus, despite Proxima B's lack of brightness. However, the most intriguing aspect of Proxima Centauri B is that it may be livable. This star is surrounded by several alternatives because it is in the habitable zone. Astronomers have therefore set out to determine the outermost bounds of this star's potential. For instance, the James Webb Space Telescope can be useful. Finding light from the first galaxies and stars to develop in the universe after the Big Bang, studying the formation and evolution of galaxies, gaining a better understanding of the formation of stars and planets, and investigating planetary systems and the origin of life are the four primary objectives of the JWST. These initiatives, which range from SETI to exoplanets, are moving closer to their objectives of discovering extraterrestrial life. The exoplanet in question is still being explored by the JWST. What exactly is SETI, many might ask? Poking and probing at anything that moves or doesn't has always piqued people's interest. This is the reason SETI grew to be such a large undertaking. Imagine that God has orchestrated a massive treasure hunt in space. But there's a catch. We're supposed to be searching for signals, more precisely electromagnetic whispers, from societies beyond our wildest expectations rather than riches. Search for extraterrestrial intelligence is what SETI stands for. Our team's goal is to look for evidence of sentient life beyond the stars. We are constantly curious, aren't we? Shortly after the invention of radio, individuals such as Guglielmo Marconi and Nikola Tesla developed a novel concept in the early 1900s. They had the audacity to think that they would be able to touch the stars with these new devices. The notion thrilled Tesla so much that he even believed he could communicate with Martians using his wireless broadcast system. In the 1960s, we are in the midst of Project Ozma, which was developed by the courageous scientist Frank Drake. Drake used a large radio telescope and a great deal of curiosity to scan the radio waves of space for signs of life. Sadly, despite his best efforts, nothing came of it. Nevertheless, scientists worldwide tuned in their antennae to listen to the cosmic symphony as the quest continued. Meanwhile, the discussion of space also piqued the interest of our allies in the Soviet Union, which was located behind the Iron Curtain. Directed by the legendary I.S. Shklovsky, Soviet scientists tried to detect such elusive transmissions from space by aiming their antennas at the sky. The stage was thus prepared for a space battle. But what is this? Everyone became extremely tense and started chatting a lot as a strange signal called the wow broke through the background noise of space. Signal. It astonished scientists worldwide. The hunt for extraterrestrial companions in space grew more intense throughout the years. From the little SETI to the massive Project Cyclops, scientists spared no effort in their attempt to unravel the cosmic riddle. We became even more intrigued when, by some odd stroke of luck, or perhaps fate, a coded radio signal from Mars appeared on our Hubble cameras. However, how has exploration changed over time, and how far has humanity advanced in terms of space travel? Lights on Proxima B. In the 2021 research paper, Detectability of Artificial Lights from Proxima B, Elisa Taber and Abraham Loeb investigated whether artificial lights could be detected from the dark side of Proxima B. The study sought to determine whether Proxima B, a planet in the star's habitable zone, could harbor intelligent life and how to detect it. They went into greater detail about a juicy and somewhat frightening fact after discussing how crucial Proxima B is as a target in the hunt for extraterrestrial life. A potential radio signal was recently detected emanating from Proxima B. This isn't particularly new, but anything is a breakthrough when you're studying something in space, where information travels at the speed of light. Scientists and astronomy enthusiasts were very excited about the potential radio signal. Astronomers are eager to unravel the riddle it has added. The signal was detected by researchers from the Breakthrough Listen project, which may be an alien radio signal from the vicinity of Proxima Centauri, the host star of Proxima B. The project was started in 2015 with the goal of looking for indications of technological societies beyond Earth in the sky. This is done in order to listen for any type of company and to dissolve the limits of space. The project searched a vast portion of the electromagnetic spectrum for odd communications that are difficult to explain by natural occurrences using state-of-the-art radio telescopes and data analysis techniques. This search took a lot of time. The narrative is particularly valuable when it comes to the potential radio signal from Proxima B. Astronomers discovered a narrow band emission at a frequency of roughly 982 MHz as part of the study. Artificial radio transmissions, such as those used for terrestrial communication, are typically thought of as falling within this frequency range. It was a fascinating discovery that opened up a wide range of possibilities. Even if the signal hasn't been conclusively connected to an extraterrestrial source and could have other causes, the discovery is nevertheless a significant advancement in human history. It was time to examine the call in order to have a better understanding of the signal now that it was established. The Breakthrough Listen team meticulously collected additional readings and conducted data analysis. Determining the likelihood that it originated from another planet was the aim. Despite the fact that the signal has been examined all the way to the sun and back, no definitive conclusions can be made as yet. The vast, empty universe is not as simple as we would like it to be. 1,000 issues, disruptions, and interferences from earthly sources will skew the results. However, astronomers cannot proceed with inaccurate information because space missions are extremely expensive and require careful execution. Since the solution is unclear, it is impossible to make a mistake. Nevertheless, there is always hope for the future. We might be closer to solving the world's secrets than we realize with the technologies we now possess. The significance of artificial light as a marker of technologically evolved societies that use lights as guides is emphasized in the study. According to the paper, since Proxima B is tidally locked and has a perpetually dark side, using this type of technology could make our travels considerably more sophisticated. Artificial light is necessary for technology to exist there. A variety of factors are examined in order to determine the light curve. These could include the orbit's tilt, albedo, duration, and the radius of the planet and the star that supports him. The purpose of all this is to give you a sense of how simple it will be to locate the phony lights. It also discusses how to determine light curves using the Earl model of exoplanet analytic reflected light curves. This is accomplished by including a metric that indicates the amount of artificial light present on Proxima B's dark side. The study uses the James Webb Space Telescope, JWST, and its NIRSPEC instrument to mimic signal-to-noise computations. Again, this is done to check for the presence of artificial lights. After then, the results were collected and examined. According to them, there should be an 83% chance that the James Webb Space Telescope would detect artificial lights of the LED variety, which account for around 5% of stellar power. The current spectral band must be 103 times smaller only to detect the quantity of artificial light on Earth, but 85% is a significant leap over previous results that were unclear. The primary topic of discussion at the moment is the possibility of strategically placing mirrors to illuminate Proxima B's eternal day and night side. This clever technique could help identify false lights. The study's conclusion raised the possibility of future expansions. Even though we can't predict the future, employing upcoming telescopes like LUVOIR could be a significant advancement for improved identification. James Webb determines the atmosphere of Proxima B. How humans are able to perform such complex math is a mystery. Traveling to the moon seemed like a wild notion thousands of years ago. We can now accurately guess, compute, and analyze planets that are light years away. Indeed, one of the best indicators of human progress is our instruments, particularly the James Webb Space Telescope, JWST, the most potent camera we currently possess. The James Webb Space Telescope, JWST, will transform our understanding of other planets' environments and atmospheres. Yes, Proxima B is also included in it. Its sophisticated observing abilities are intended to be used to carry out these ambitious goals. One of the most crucial instruments on the JWST is the Near-Infrared Spectrograph, NIRSPEC. It is essential to locating, categorizing, and ultimately understanding other worlds' atmospheres. Its great spectral precision and high sensitivity allow it to achieve that. Like breaking two strands of hair, astronomers can also divide the light from distant exoplanets into smaller bits. This makes it simple to identify the signatures of significant gases in the atmosphere, such as water vapor, carbon dioxide, and methane. As the saying goes, where there is water, there is life, almost always. The protagonists in Interstellar may feel differently about this after encountering the enormous waves of the water planet. Our actions may appear to some to be magical, leading them to believe that we are holding a magic stick. This detailed spectroscopic analysis typically provides us with critical information about the atmospheres and potential habitability of exoplanets, such as Proxima B. The JWST mid-infrared instrument, MIRI, is also a human tool. It provides us with other methods to investigate other worlds' atmospheres. The mid-infrared region of the electromagnetic spectrum is where MIRI's imaging and spectroscopic modes operate. This enables researchers to investigate the heat outputs from exoplanets and investigate their temperature profiles, cloud formation, and atmospheric motion. These trials might lead to a greater understanding of the world and ultimately its appropriation. Scientists can better comprehend the composition and structure of Proxima B's atmosphere by combining data from NIRSPEC and MIRI. Additionally, the JWST's unparalleled sensitivity and observational capabilities enable astronomers to detect and examine Proxima B's weak signals, which is challenging to achieve when Proxima Centauri, its host star, is bright. Technology such as JWST allows us to overcome this type of limit. The James Webb Space Telescope can see through it since it is rather large. That offers us the advantage we require when combined with the telescope's state-of-the-art instruments. Because of this, the JWST can easily detect minute variations in the light that the exoplanet emits or reflects. These discrepancies might not seem significant, but they are the key to understanding the temperature, surface characteristics, and potential indications of geological or atmospheric activity of Proxima B. The JWST is prepared to investigate more than the atmosphere of Proxima B. Additionally, it will investigate its surface characteristics, orbital dynamics, and potential interactions with its host star. We were able to determine whether Proxima is a good area to reside thanks to this technology. The most significant finding regarding the environment of Proxima B is that it is extremely bright, following the 2018 research report, The Habitability of Proxima Centauri B. According to the study, the main risk that could render the exoplanet inhospitable is the brightness rise of its M-dwarf host. The pre-main sequence phases of M-dwarf stars can last for up to 1 billion years because to their lower mass. Compared to when they settle into the main sequence, they are more brighter during this phase. It was discovered that the terrestrial planets emerging in the future habitable zone are currently facing significant challenges due to this extremely bright pre-main sequence era. Are you curious as to why? Oceans can be immediately transformed into gas and light by the huge levels of radiation released during this phase. It's like getting zapped and then you're gone. On planets that are still expanding, it can also eliminate light components from their atmospheres. According to simulations these scientists performed, Proxima Centauri B would not have been safe until 169 million years after its formation. Proxima B is not likely to be a good place to reside in light of this new information. Aside from space communications, artificial lights, and superplanets, the realm of space travel is frightening, unpredictable, and thrilling, especially in light of James Webb's search for extraterrestrial life. The space research and development industry is also expanding at the speed of light. Therefore, it may not be long until ordinary people can move around the moon with ease. In this instance, the moon is already in the sights of NASA and a few private companies. By 2025, NASA's Artemis program hopes to begin constructing a base camp so that humans can dwell on the moon. This is a significant but intriguing objective. While aspiring to live on the moon for an extended period of time is undoubtedly courageous, it is also significant in certain ways. NASA can prepare for even longer and more extensive human space travel by keeping these ambitious objectives in mind. Who knows? Perhaps one day it will also involve an aircraft with passengers. This is undoubtedly true, as evidenced by Elon Musk's incessant thoughts of settling humans on Mars and giving them a sense of belonging. As a very human gesture, Elon Musk's firm, SpaceX, has even stated that they wish to establish themselves on Mars. They have even stated that a human colony on Mars is necessary for human survival, and they intend to accomplish this via the Starship launch vehicle. People have demonstrated that nothing can stop us from evolving, not even space. There are certain terrifying facts about space that could one day fundamentally alter our perspective on it, even if we are not able to survive the future. What are your thoughts? Do we have a good chance of finding extraterrestrial life? Please use the space below to express your thoughts and emotions.